Hello friends, thank you for choosing this particular course and I really appreciate it. And you're going to learn after this particular course is over, you're going to learn a lot more about chemistry, their basic concepts that are there related to chemistry. And I hope that after this course, you're going to enjoy a lot of chemistry around you. So, as you all know that I am Dr. Rashi Chopra and I'll be dealing with lot many courses. I'll be putting on lot many courses as well and lot many chapters as well for your own benefit, for your own learning in chemistry. As of now, this is where we are going to start, which will be some basic concepts of chemistry, and this particular course is in various parts. So, in the part one of chemistry today, what we are going to learn here would be the basic definition of chemistry, what is the importance of actually studying chemistry, knowing the knowledge of chemistry, why it is required, what is the necessity of it. Then we'll be discussing about how you can classify what are matters and how can you classify your matters into two levels of macroscopic or bulk level and into microscopic or particle level. This is what we are going to discuss in this part. And as this particular screen that you are seeing you can imagine that this is the basic of all the chemistry that you know till now, till this particular class, this particular level that you know. This is what you know right now. You know about solid liquid gases, you know about element compounds and mixtures, but we are going to discuss it again because these are the basic foundation of chemistry. So let's understand what is the basic definition of chemistry first. Actually, different scientists, they give you different definitions of chemistry, but if I have to deal with, or if I have to tell you the definition of chemistry, and in a very simple manner, if I just say that chemistry is study of matter. So whenever I want to study matter, I take the help of chemistry. So let's understand first what is matter. First, let us know what is matter. Matter is something that has mass and it occupies space. So anything that has mass and occupies space is called as matter. So for example, let's say you have your pen is a matter because it has some mass and it is occupying some space. Your bed is a matter because it still has some mass and it occupies some space in which you have kept it. Chair is a matter, television is a matter, computer is a matter, laptop is a matter, book is a matter. Anything that you see around you is a matter. You yourself is also a matter because you have some mass associated with yourself, as well as you occupy certain space, right? So you are also a matter. So whatever you see around you are matters. So anything that has mass and occupies space is a matter. Now any item, any substance that occupies space, I can also say that it will have some volume associated with it because it is occupying some space. So I can also redefine matter another way, which is matter is something that has some mass and has some volume. So either I say it occupies space or I say it has volume. It's one of the same thing because anything that occupies space will have some volume associated with it also. So matter is something that has mass or occupies space, or matter is something that has mass and has some volume associated with it. So when you study those matters, when you study the matter, the substance around you, which has mass and volume, then that is done by the branch of science called as chemistry. And what do you study? What all do you study for matter? You study the composition of the matter, you study the structure of the matter, how it is made, what is the structure, and you study the properties of the matter. You study what are all the physical and chemical properties of the matter. So in chemistry, all in all, now I can define in a proper manner, I can define it as chemistry deals with the composition, structure and properties of the matter. Okay, so chemistry is that branch of science that deals with the composition, structure and properties of a matter. Alright, or in other way, chemistry deals with the study of matter. Simple. Now, earlier, scientists used to say that matter itself is a substance as such. It cannot be divided further. But now, we'll study about Dalton's theory later on. But we all know that after some time, the scientists started saying no, that matter can be further divided into smaller particles called as atoms and molecules. Thus, we can say that the matter is divisible, and it is divisible into atoms and molecules. These atoms and molecules are indivisible particles, and matter is made up of these indivisible particles called as atoms and molecules. So all in all, again, I can just define my chemistry in another way, that chemistry deals with the study of atoms and molecules. So if I say chemistry deals with the composition, structure and properties of matter, it's right. If I just say chemistry deals with the study of matter, it is also right. And if I say chemistry deals with the study of atoms and molecules of which the matter is made up of, that is also right. So anybody can define chemistry in any which ways. All the three definitions are correct. Okay. So let's understand now what is the importance of chemistry, why I need to study chemistry. Now please remember, chemistry as such is divided into three particular categories. Okay, in chemistry there are three individual categories that you study. One is called as inorganic chemistry. In inorganic chemistry, what you study are all the elements of the periodic table, okay, which the elements which are there in the periodic tables, which you have got, which are not got organically, you have not got from which are not nature made. So all those elements in the periodic table except carbon and hydrogen, all the elements in the periodic table are studied in the inorganic chemistry. Then comes physical chemistry. In physical chemistry, what all do you study? It's another branch of chemistry in which you study the physical properties of the matter. Let's say, for example, you will study temperature changes, you will study pressure changes, you will study volume changes. So all those physical changes, density changes. So all those physical changes of a matter is actually being studied under the branch of physical chemistry. Okay. The third branch of chemistry is called as organic chemistry, and under organic chemistry, as the name suggests, you are going to study the organic matters. So what you study under organic chemistry are basically hydrocarbons. And what are hydrocarbons? Hydrocarbons are the substances that are made up of carbon and hydrogen mainly, but they can also have certain amount of nitrogen and oxygen associated with them. So, study of hydrocarbons is organic chemistry. Study of periodic elements are when you study their properties and everything, they come under the fall of inorganic chemistry. And when you study the physical properties of the matter or elements or compounds, that come under the uh, under physical chemistry. So basically, science is a broader branch that came into existence by the man itself. It's a man-made field, and man made this particular field of science and technology for its own convenience, because you get lots of solutions to a lot of man-made or human problems. So science is a branch which is a broader branch, which is made by man itself for its own convenience. And under science you have various branches like physics, biology, geology, and chemistry is one of the branch of science. Okay, astrophysics, and all these things, they all come under the branch of chemistry. All right. So now, like next we would come that why there is a need. Now I know about chemistry. I know about what are the branches of chemistry. I know about there are various other branches of chemistry as well, but the broad three branches are inorganic, organic, and physical. And we know about that science is a broader category, and under that a lot of small little branches comes into existence. But why I need to study chemistry? Still there is a doubt why I need to, because chemistry has its importance in our daily life. It has its importance in community. It has its importance in health sector. It has its importance in environments. It has its importance in medicine, drug industry basically, and it has its importance in science, in teaching, in research, and in you yourself also. It has a lot of importance because inside your body also you have a lot of chemicals which act and keep your system, your pH or whatever your brain system, everything, it keeps under control, so that a human body can or your body can act appropriately. So chemistry is actually it's important in our daily life uh, in various ways. For example, let's say I want to predict weather patterns, whether I want to say whether it would be cloudy, it would be sunny, it would be having a lot of moisture outside. So weather patterns can be only predicted if I know the phenomena of evaporation, condensation, and so on and so forth. So if I want to predict what would be my weather pattern, I have to have the importance of chemistry, the knowledge of chemistry. Functioning of the brain. In human body, how my brain functions, because there are certain elements like sodium and potassium that pump inside and outside of your brain, and because of that the signaling occurs, and since the signaling occurs, the brain can function and can tell your body that you have to sit, you have to stand, you have to put your make your hand up, you may have to keep your hand down, and so on and so forth. What do you have to say, everything. The functioning of the body is controlled by a lot of elements and enzymes inside your brain that functions, and these are all chemicals that are inside your brain. And because of that you need to have the knowledge of chemistry so that you know how the brain functions. In the chemical industries, one of the biggest industry in the chemical industries, manufacturing of the fertilizers, acids, alkali, soap, detergents, alloys, and metals that are used in our day-to-day life are all manufactured in these industries. And knowing how they can be manufactured, what would be their composition for their effective usage, can only be determined if you have the knowledge of chemistry. Even in the drug industry, manufacturing of various life-saving drugs like cisplatin and Taxol, which fight against cancer, can be done or can be made, and its composition can be detected only and only by the knowledge of chemistry, knowledge of the analytical tools in chemistry, so that you understand what percentage or what amount of the drugs is required for a particular, or what dosage of the drug is required for a particular disease. Also, in the last section, the production of conducting polymers and optical fibers can only be done. There are a lot of conducting polymers and optical fibers. They conduct the signals, and optical fibers conduct signals at a very fast pace. Now, how can they be prepared? How can they be manufactured? What should all the elements should go into it so that the conduction of the signal becomes easy, or conduction of a thermal conduction becomes easy. If I'm talking about conducting polymers, it can be thermal, electrical, so on and so forth. So the conduction becomes easy, more efficient, and how they can be prepared, what all elements can go in them, how can they be used, all these things, all these problems can be solved by the knowledge of chemistry. And there are a lot many things also that chemistry can do, so there in our daily life also. Like for example, we all know that you convert your milk to curd in your households, and how the yogurt or curd is made through milk is all the chemical processes that are involved when milk is converted into yogurt. So all these things and lot of things are there, which I've not discussed, but yes, they are there, which actually tells you that knowing chemistry, having a knowledge of chemistry, in-depth knowledge of chemistry is very important to understand the phenomena occurring around you. Now let's understand what would be the nature of a matter. Now there are two types. We can classify the nature of any matter. How a matter would look like. It would be we can classify them in two ways. One would be at the macroscopic or bulk level. Macro means big. So at a macroscopic or a bulk level, we can classify matter into two forms. One would be mixtures, another would be pure substances. Okay. Uh, Mixtures, first let's talk about mixtures. So mixtures are those in which two or more components are present in any ratio. Please remember, in any ratio. So in mixtures, what happened, there can be two or more than two components that would be present in any ratio. There is no fixed ratio. For example, I take some water, I add some sugar to it, and also I add some salt to it. Now, and I mix them together. So what I'm doing is I'm making a mixture. Why I'm making a mixture? Because I have not measured my amount of solvent, that is water. I have not measured my amount of solute, that is my sugar and salt that I have added into the water. So nothing is being measured and it has been randomly added. So what I have got is a mixture. So when I add two or more components in any ratio, what I end up into a formation of a mixture, right? So and mixtures are also matter, please, because it's a category of a matter itself. Now mixtures can further be divided into two. One can be a homogeneous mixture and other can be a heterogeneous mixture. Now homogeneous means same. Homo means same, uniform. So whenever you add two or more components in any ratio and you get a uniform solution, then such mixtures are called as homogeneous mixtures. For example, sugar solution. If I take some water and add some sugar to it and I just stir it, then what I'm going to see, when you see the solution is uniform. I cannot differentiate between sugar. I cannot differentiate between water. So it's a uniform solution. So such solutions are called as, they are mixtures, because I've taken water and sugar in any form. I have not measured it. It's a mixture. But what kind of a mixture? It's a homogeneous mixture, since the solution has a uniformity in it. Okay. Air is also a homogeneous mixture, because air is also made up of large number of gases like nitrogen, sulfur, oxygen, carbon dioxide, carbon monoxide, and I cannot differentiate that there only oxygen is present, here only nitrogen is present. No, it's uniform. All the gases are uniformly mixed in air, and I cannot differentiate between where is oxygen present, where is nitrogen present. I cannot differentiate that. So air is also a mixture, and with what kind of a mixture? Homogeneous mixture. Now let's talk about another classification of a mixture, which is heterogeneous, and this is just opposite to homogeneous mixture. In heterogeneous mixtures, what you will see would be non-uniformity in the solution. That is, the components will be visible by the naked eye. For example, let's say uh, I have some water and I just add some sand particles to it. Now, and I just mix it. After some time, what you're going to see is that the sand settles down, and in the on the above layer there would be only water layer. Okay, so I can see from my naked eye that I can differentiate between the components, two components, sand and water, that I had mixed. And when you can differentiate the components from your naked eye, since the layers are formed, such mixtures are called as heterogeneous mixtures. For example, uh, let's say I take some grain, and in grain you will see some dirt stones also. So when your grain and pulses have dirt stones, so the stones can be seen in the grain and pulses, and you can automatically differentiate between the stone and the grain or your pulses that you have bought. So uh, the mixture of grain and pulses with some dirt stones is also a heterogeneous mixture, because you can easily see the dirt stones in grain and pulses. The second kind of matter, the second classification of the matter at the macroscopic level are called as pure substances. Pure means, in chemistry, pure means that if anything would be there in a fixed ratio. So when if something is present in a fixed ratio, it is called as a pure substance in chemistry. So Pure substances are the components, are the substances in which the components would be present in a fixed ratio, unlike mixtures where the components can be present in any ratio. So in pure substances, the components are very much present in a fixed ratio. Okay, for example, let's say I have a copper element. Now, in copper element is an example of pure substance, because in copper element, the copper element would be made up of what? Copper atoms, and only the copper atoms, and copper atoms, there would be some amount of copper atoms which would be fixed. Okay, that what amount is there will depend upon what weight of copper element we are talking about. We'll do it in mole concept, but here just understand that if I'm taking a copper element, a copper element is an example of a pure substance which will be consisting of only the copper atoms, and the copper atoms will be present in a fixed number in copper element. Okay. Now, the pure substances are further divided into two categories, elements and compounds. Now, what are elements? Elements consist of only one type of particles, that is atoms or molecules. There will be single type of atoms or molecules. For example, we have just discussed about copper element. Let's say I take gold, Au. Now, in gold also, gold element will also be present, will be made up of only the gold atoms, and the number of gold atoms would be fixed. Okay, so copper and gold are the example of elements, because these are elements which are made up of single type of atom. Okay, the copper element is made up of only copper atoms, and gold element is made up of only gold atoms. Let's talk about compounds. In compounds, two or more atoms, they combine to give a molecule of a compound. That is, for example, in this there would be two or more different atoms. Please remember. For example, glucose. Now, glucose is C6H12O6. Now, glucose is made up of carbon atom, hydrogen atom, and oxygen atom. That is, in glucose there are three different atoms that are present, which are carbon, hydrogen, and oxygen, which will be present in a fixed ratio, which is 6:12:6, or I can say 1:2:1. Okay, so the ratio of the uh, of the atoms in the compounds will always be in a fixed ratio, and compounds are made up of two or more different atoms, while elements are made up of single type of atom. Okay, another difference between, if I say talk about mixtures and pure substances, mixtures can be easily separated by physical methods. Okay, like hand picking. Now, if I have a grain or a pulse containing, if I have a heterogeneous mixture of grain and a pulse containing some dirt stones, and I can see my dirt stones, so I can easily remove my dirt stones through a process called as hand picking from my grain and pulses. Filtration is another method to remove your components from each other in a mixture. For example, let's say I have sand and water, so I can just use a filter paper and pass my solution through the filter paper. The sand will remain inside the filter paper, and what I will get in the beaker is my water. So filtration is another method to remove the components or to separate the components of a mixture. Crystallization is another method to separate the components of the mixture, and distillation is also one of the method to separate the components of the mixture. So for example, let's say I have a mixture of salt and water, and I want to just separate salt and water. So what will I do? I'll just boil my mixture, and what will happen? Water is going to get evaporated. What is left behind is the salt. So mixtures, be it homogeneous mixture or a heterogeneous mixture, does not matter. But mixtures as such can be separated by physical methods. But pure substances, components cannot be separated by physical method. I cannot separate my carbon, hydrogen, and oxygen atoms by simple physical methods in glucose. I have to use some chemical methods. I have to use those methods which are chemical methods to separate the components of my pure substances. Okay. Is asked in some question papers, entrance exam question papers or otherwise also, You are in the question, what happens is you are given some assertion or some statement. Here the assertion or statement in the question was, a homogeneous mixture is formed by mixing two or more components to form a compound. Okay. Then in the question itself, a reason statement is also given, in which it is said a homogeneous mixture cannot be separated by physical methods, and four options are given. Let's say in option A it is given that assertion is right, reason is wrong. In B option it is given reason is right, assertion is wrong. In C option it is written assertion and reason both are right. And in the D option it's written assertion and reason both are incorrect. Now you have to choose. Now first you need to understand what in the question, what is the assertion statement meaning. Assertion statement says the homogeneous mixture is formed by mixing two or more components. Yes. To form a compound. No. Please remember, whenever a mixture, be it homogeneous, be it heterogeneous, whenever a homogeneous or a heterogeneous mixture is formed, no compound is formed, they simply mix with each other. There is no compound formation. Otherwise, we would have kept homogeneous or heterogeneous mixtures in the category of a compound. We have not kept in the category of a compound. We have said they are in the mixture category, and mixtures do not form compound, they simply mix with each other. That is why they are called as mixtures. So homogeneous mixture are formed by mixing two or more components, yes, but they do not form a compound. Okay, so assertion is wrong. Then the reason statement was homogeneous mixture cannot be separated by physical methods. I've just told you, be it a homogeneous mixture or a heterogeneous mixture, it can be separated by physical methods. So reason is also wrong. Thus my answer D option, which is both assertion and reason are incorrect, is the right answer. Alright, next. Now so far we had discussed about what is the definition of chemistry, and we have discussed about the importance of chemistry, and we have classified the nature of my matter into the first level, which is at the macroscopic or bulk level. The other way of classifying my matter would be at the microscopic or particle level. Okay, the thing which you cannot see, which you think, the level at which you can see at the microscopic level or particle level, the matter can be classified into solids, liquids and gases. Now in solids, the particles are arranged very tightly. These red circles represent the particles. So if the matter is in the solid state, the particles would be arranged very tightly to each other in an ordered fashion, and there would be hardly any movement of the particles. So particles will not have any freedom of movement since they are held very close to each other in an ordered fashion. The solids, they have a definite volume and a definite shape. Obviously, since the particles are very close to each other, they cannot move, so they do have a definite volume and they do have a definite shape. You cannot change the volume and shape of any solid. You cannot change the volume and shape of your pen. You cannot just change the volume and shape of your book, right? So they are all solids. So they have a definite shape and a definite volume. Solids have no fluidity. Yes, because they cannot flow. Okay, your pen cannot flow like that. Okay, your books cannot flow like that. So they have no fluidity. They are non-compressible. Yes, on applying some pressure, they do not compress. So since they do not compress, they do not deform, the solids are non-compressible. Let's come, if any matter is in the liquid state, then the particles would look like this. They would be a little, they would not be very close to each other. They will have some movement is there in them. So they will definitely be having certain movement associated with them. So there would be some movement, and uh, the liquids, they have a definite volume but they do not have a definite shape. For example, let's say I have a 1 liter of water. Now the 1 liter water is going, let's say the 1 liter of water it is having a definite volume. The 1 liter water, if I keep it in a container, let's say I keep it in a bucket, it will take the shape of the bucket. If the same 1 liter liquid water is kept in a jar, it will take the shape of a jar. All right. So The liquids, they have a definite volume. It was 1 liter. Okay, so volume is definite, but the shape changes. The liquids take the shape of the jar in which they are kept. The liquids do have fluidity, yes, now because the particles are little away from each other, they flow. So liquids do flow, so they have fluidity, but still the liquids are non-compressible. Now, why they are non-compressible? Let's say, for example, I take a syringe and I add some liquid to it, okay, and I close the mouth of the syringe. Now, from backside, I push the piston inside. Now, when I push the piston inside from backside, the piston does not, what I'm trying to do is I'm applying some pressure, right? Now, the piston does not go inside, it does not change its fate, it does not move inside. This means that the liquids are non-compressible, because on applying pressure, since I'm applying pressure to the piston, so if the liquids would have been compressible, then the piston would have moved inside. Now, okay, now since the piston does not move inside, the liquids are non-compressible. That is, on applying pressure, they do not compress. Now let's talk about gases. And if your matter is in the gaseous phase, then the particles would look like this. The particles would be far away from each other. There would be easy movement among the particles. They are not going to have a definite shape and a definite volume. For example, let's say I have a deodorant can. Okay, I have a deo can in which the gases are put inside the can under high pressure. Okay, so okay, so that means that there would be some volume of my gas. And what would be the volume of the gas in the deodorant bottle? It would be just same as the volume of the deodorant bottle. So whatever is the volume of the deodorant bottle, that would be the volume of the gas, because the gas is going to occupy whole of the space of the can of the deodorant bottle. Now if I break the can, and then what will happen, that the gas is going to escape, and it will occupy the space of the entire room. Okay, now what happened? Now, earlier the shape of the gas was the shape of the deodorant bottle, and the volume of the gas was the volume of the deodorant bottle. But now when you have broken the deodorant bottle, what is going to happen? The gas will get will find its space inside the room. Now, the shape of the room would be the shape of the gas, because it will occupy whole of the space of the room, and the volume of the room would be the volume of the gas. Okay, so the space that any substance occupy is equal to its volume. So earlier the space that the gas was occupying was the space of the deodorant bottle, but now the space that it is occupying is the space of the room. Thus the shape and space, or the volume, both changes for a gaseous particle, and therefore they do not have a definite volume, they do not have a definite shape. Now, gases have high fluidity. Yes, they flow very easily, and they are highly compressible. Gases are highly compressible. That is why you apply pressure to the gases, and they fit inside the deodorant bottles, right? So they are highly compressible. So these are the three states of matter at the particle level. Okay, this is the nature of the matter at the particle level. Now, by changing the temperature and pressures, we can easily change the state of the matter. So if I have a matter in the solid state, I can easily change it to a liquid state by increasing the temperature, that is heating, providing some heat. So it will melt. So solids will melt when I provide some heat to them. So if I heat them, or I increase the temperature of my solids, then they will convert into liquid. They will melt and convert it into liquid. So, or by decreasing the pressure. Okay. If I want to, if my matter is in the liquid state and I want to change its states to the gaseous state, then what will I do? I will again increase the temperature, decrease the pressure, and the liquid will change into gaseous state, called as evaporation. Similarly, if I want to change my matter in the gaseous state to liquid state, I want to decrease the temperature, increase the pressure, and I have to do the process of cooling, so that the gas can be changed into liquid. Similarly, if I want to change my liquid state into a solid state, again I have to decrease the temperature, increase the pressure, so that my liquid particles, they come close to each other and they get converted into solid state. So all the three states of matter are quite interconvertible into each other on changing the temperature and pressures. This is the last part of the today's last part of the session. This is a diagrammatic representation that differentiates between the atoms, molecules, and compounds. Now, let's say this first section describes the atoms of different elements. So, this is the atom of hydrogen element, this is the atom of oxygen element, this is the atom of nitrogen element, this is the atom of copper element, this is the atom of sodium element. And all these atoms, they will be only composed of protons, neutrons, and electrons. So the nucleus of these atoms are going to have protons and neutrons, while the orbitals around them are going to have electrons associated with them. Okay, so these are just the atoms of different elements. Now when two same atoms, they combine with each other and they form bonds, they form a molecule. So when one hydrogen atom combines with the second hydrogen atom, they form a bond with each other and they form one molecule of hydrogen, H2. One atom of oxygen combines with other atom of oxygen, they form a bond and forms a molecule of oxygen, O2. Now, there is a slight difference between compounds and molecules, and most of the time the compounds and molecules are actually they're generally synonymously be said that they are synonyms to each other. And but there is a little slight difference, is that when same atoms, they combine with each other, they form a molecule, but when different atoms, they combine with each other, they form a compound. Okay, so when one hydrogen atom combines with one oxygen atom and one hydrogen atom under electric spark, because such a reaction does not take place under normal conditions, they form one molecule or a compound of water, H2O. Okay, so either you can say molecule, either you can say compound, they are used very synonymously, but there is only a slight difference wherein bonds are formed in both the cases. The only slight difference is when same atoms are combining, they are called molecules. When different atoms are combining, they form compounds. One atom of oxygen combines with one atom of carbon, another atom of oxygen, to form carbon dioxide molecule or a compound. So today what we have discussed is the basic definition of chemistry, the importance of studying chemistry in day-to-day life, why, what is matter, what is the nature of the classification of matter at the macroscopic and microscopic level, and this diagrammatic representation we have done that just differentiates between atom, molecules, and compounds. So for today's session, this is till then, this we're going to do, we'll do further in the next class. So much.